Hey everyone, welcome back to another episode of Quick Bites of AI. I'm your host, your friendly neighborhood AI enthusiast, and today we're tackling a topic that might sound a bit imbalanced. Yep, we're diving into the world of data imbalance in machine learning. So, let's first get our heads around what data imbalance actually means. Imagine you're at a party. There are hundreds of people, but only two types of snacks. Say, cookies and carrots. Now, imagine that 95% of these snacks are cookies, and the rest are carrots. If you were a machine learning model learning to recognize snacks at this party, you'd probably become a cookie connoisseur pretty quickly and, completely ignore those poor carrots, right? That's data imbalance for you. It happens when one class or category in your dataset is significantly outnumbered by the others. Why does this happen? Well, in many real-world scenarios, some events are naturally rarer than others. Like, fraud detection. Most transactions are legit, and only a few are fraudulent. Or maybe in medical diagnostics, where thankfully, most patients are healthy, and only a few have a particular condition. So when we collect data from these scenarios, we end up with these lopsided datasets. Okay, moving on. Why is this a big deal? Well, because our beloved machine learning models, they're kinda lazy. I mean, who can blame them? If they see that one class shows up way more frequently than another, they'll take the easy way out and start ignoring the underrepresented classes. It's like the model equivalent of binge-watching your favorite sitcom and skipping the commercials. It just doesn't pay attention to the less common but often more important data. So how do we know if our dataset is imbalanced? Simple. Count the instances of each class. If you're, seeing a 90% to 10% split or more extreme, it's a good indication you have an imbalance issue. The term simple might be a bit of an understatement here. But hey, we gotta start somewhere. Now let's talk solutions, because nobody wants a lazy AI model, right? One way to handle data imbalance is, basically doing the opposite of what most diets suggest: oversampling. This means creating more instances of the minority class, kind of like magically multiplying those rare carrots at our snack party. Another way is undersampling the majority class, but that might be like taking away all your cookies until you've got an equal snack proportion. Be warned, this could leave you with less information to work with. We've got fancier methods too, like SMOTE, which stands for Synthetic Minority Oversampling Technique. It's kinda like cloning your carrots, but not in a freaky sci-fi way. Instead, it creates synthetic variations of the minority class, making the dataset more balanced without getting too repetitive. And let's not forget cost-sensitive learning. Instead of changing the dataset, you could make your model a little smarter about the imbalance by punishing it more for misclassifying the minority class. It's like giving it a tap on the wrist for ignoring the carrots. An example? Sure. Think about customer churn prediction. You probably have loads of data where customers are staying, and only a few where they decide to leave. By balancing this data through one of the techniques we just jibber-jabbered about, you make your model better at spotting those potential leavers before they actually leave. Now for the twist, can data imbalance ever be, a good thing? Funny enough, sometimes focusing on an imbalanced dataset can drive innovations in model design and error analysis. It's like having a more challenging puzzle to solve. Machine learning folks, they do love their puzzles. Alright my friends, that wraps up our chat on data imbalance. Remember, in the wild world of AI, balance is key. But knowing when to embrace imbalance can lead to even greater insights. Thanks for tuning in to Quick Bites of AI. Catch ya later at our next episode, where we break down another bite-sized AI concept. Stay curious and, well-balanced.